Hello everybody at AGU, this is Miu Sambara. I'm a cell and molecular bio major here at the University of Rhode Island, and recently over the summer I took on an internship with the geology department, and I worked with Hisham and Sony Pradhanang in designing a water pump. So first I want to start out by mentioning chlorine. So chlorine is a disinfectant that is used widely in water plants these days. So most water plants that we have conventionally here in the US use chlorine to disinfect water. So by using chlorine, we can eliminate microbes and microorganisms that are pathogenic, and thus we can reduce disease that is transmitted through water. So the reason why this is bad is because chlorine is actually a very harmful chemical when it's ingested by humans. So the reason why this is because medically, if we're looking at chlorine, when it's ingested, it actually you have a higher chance of contracting cancer or getting cancer when you take in chlorine. The reason why this is because in the human body, there's something called the thyroid gland. The thyroid gland is a gland up in your throat. No. In the human body, there's a gland called the thyroid gland. In the thyroid gland, although there are many water plants that use chlorine, some of them have opted to use filtration devices to reduce the amount of chlorine in the water. Now some of these, such as Optipure, which you see in the picture right here, have decided to use filters and filtration devices that would reduce the amount of chlorine, thus reducing the harm done through chlorine. Now the CDC imposes that there should only be 4 milligrams of chlorine to 1 liter of water. Now the reason why chlorine is so harmful is that it actually has a high chance of giving somebody cancer. Studies have shown that people have a 93% more chance of getting cancer if they ingested or are exposed to chlorine than other people that haven't ingested or have been exposed to chlorine. So somebody drinking chlorinated water has a 93% chance more than somebody who doesn't to contract cancer. So now the reason why this is because in the thyroid gland, when chlorine is ingested, it can act as sort of an inhibitor, and the thyroid takes in iodine. Now, when you have other molecules that are negatively charged, like other halogens, like bromide, chlorine, all these other molecules, when they're in the thyroid gland, the thyroid senses the negative proportion, so it will take the chlorine instead of the iodine. And when it takes the chlorine in, it actually inhibits the use of iodine, which inhibits the function of the thyroid gland. Now, if the thyroid gland is minimized and loses its function, it can cause cancer. Hisham actually had an idea to make a water device, a prototype, benchtop prototype of water treatment device. And this prototype would essentially not use chlorine for disinfection. All we would use is GAC, PAC, and biosand. Basically, GAC is granulated activated carbon, PAC is powder activated carbon, and biosand, which is basically a mixture of anthracite and sand. So, in order to begin this project, we came up with the design for the pump. Now, we have 2 polyplastic tubes, which are filled with, one of them is filled with our granulated activated carbon, and the other one is filled with our biosand and the powder activated carbon. Now, the water runs through that initial tube here. Water's running through the reservoir in the tube here, running up through the 2 tubes and back into our outlet, which is right here. And that's where the water ends. So by doing this, we theorize that it is only enough to use the GAC, the PAC, and the biosand to disinfect the bacteria. Now our methods before we actually start pumping is we need to first coagulate whatever solids are inside the water. Now, through the process of coagulation, we need to use a chemical in order to bind to those solids and bring them up and raise them to the surface of the water. Now, the chemical that we chose to use is ferric sulfate, which is mainly used in other in water plants, and this chemical is fairly safe. So the initial goal of this experiment was to run a liter of water through our pump at a given flow rate and only have it done in 10 minutes. Now, the reason why we chose 10 minutes is because that's the CDC recommended, or that's actually the recommended value for water pumps to have. Since this project is in its initial phase, we haven't had many decisive results. However, we did get some observations and some achievements from the experiments we've done. Now, one of these is that we were able to achieve a desired flow rate for the pump within a time span of 10 minutes. And another thing we also did was that we conducted a bromide tracer test where we were able to remove the bromide from our system in the span of an hour. Now, we also conducted a few of the disinfection tests using some types of bacteria, but we're yet to draw conclusions upon these tests, but it's looking like it will be a positive result. And the goal at the end of this project is to basically create a water filtration device that does not use chlorine. Thank you for listening. You have a good day.